Okay, so let's look at the last couple problems from our Unit 12 review. So let's see, we got a scoop of ice cream, diameter 6 centimeters, which means the radius is 3 centimeters. Place in an ice cream cone with diameter 5 centimeters. So here's the circle on top. The diameter is 5 centimeters, so the radius is 2.5 centimeters. And the height is 12 centimeters. So the question is the cone big enough to hold all of the ice cream if it melts? Well, that means we got to compare the volumes of the two things. So we want to see, is the volume of the ice cream bigger or smaller than the volume of the cone? So let's take a look. Volume of the ice cream. So it's a sphere. The volume of a sphere is 4/3 pi r cubed. Well, r is 3 here. And if you work that out, you could get exact form for this. The 3 down here cancels with one of the 3's up there. So we're left with 3 squared, which is 9, times 4 is 36, times pi. So 36 pi. By the way, if you use decimal form, that'd be about 113.097. So let's look at the volume of the cone. So formula for volume of the cone is 1/3 area of the base times the height of the cone. Well, that's going to be 1/3. Area of the base is pi 2.5 squared. And then times the height of the cone is 12. It actually turns out this isn't too bad to do an exact form either. If you multiply out the third, the 2.5 squared, and the 12, you end up with 25 even. And then there's the pi. So 25 pi. And if you use decimal form, this would be about 78.540. So, since the volume of the ice cream is bigger than the volume of the cone would not hold all of the ice cream if it melted. Okay. And then let's take a look at the last one. The last one is harder than it looks. So you've got this triangular base for a pyramid, which I don't think we've done one of these yet. We've done various bigger shapes, but triangular pyramids, you'd think they'd be easier, but they're actually kind of complicated. Let's see, base perimeter is 21, and it's a regular triangular pyramid, so the bottom is a regular triangle. So it's 7, 7. The back here would be 7 as well, back here. Okay. And then this is the direct view of the base. So this is 7's going all the way around here. And which also means these guys are going to be 60 degrees each, which will come in handy later. Okay. This would be 7. These guys right here, this whole thing would be 7, but since that's a slant height going down the middle, we could do 3.5, 3.5. Seven here, 7 there, 7 in the back. All right. Okay, so we got plenty of stuff labeled with 7 now. The slant height is 9, which would be this guy right here. Yeah, that's fine. Okay. So let's see, we need lateral area. That one's not too bad. Lateral area of a pyramid is defined. You could do the area of one of these triangles, like VBC right here. which would be 1/2 7 times 9, and then just multiply by 3 because there are 3 triangles that look like that. Or you could do the shortcut formula, 1/2 perimeter of the base times the slant height. Whew. Sorry about the pen jamming here. So that's going to be 1/2. The perimeter of the base we knew was 21. The slant height is 9. If you multiply all that out, you get 94.5 centimeters squared. Okay, then we want the total area. Well, the total area is just going to be the lateral area plus the area of one base, which is the only base we have, plus the area of the base. So we need the area of triangle ABC. So let's see, how can we do this? There are a couple different ways you could do it. Let me just do it the way most people would probably think to do it, which is slice it right down the middle. So this angle is going to be 30 and 30 up on top. So I got a 30, 60, 90. This gets cut into 3.5 and 3.5. So we need the height. If we use the 30, 60, 90 theorem, this one would be the 60, that's 30. We've got 1 root 3 here and 2 there. So the 3.5 goes with 1, the same way that the height, or let's call that x, same way that x goes with root 3. So then x is going to be 3.5 root 3, which means that the area of the triangle here, this whole triangle, let me put the root 3 next to it, would be 1/2 the base, 7, times the height, 3.5 root 3. And then if you work that out, that's 21.21762. So that's the area of the base. That's this thing. And this is that thing. So we get 94.5 plus 21.21762. And that comes out to be about 115.718 centimeters squared. Okay, so let's go ahead and fill in these guys. Lateral area, 94.5 centimeters squared. Total area, 115.718 centimeters squared. So now we need the volume. And volume is defined for a pyramid as 1/3 area of the base, which we have, times the height of the pyramid, which we don't have. Here's the height, V to that center point down to the bottom. Okay, so what we need is some sort of triangle that we can work with here. How do we want to do this? Why don't we try to find this length right here? Okay, so that length, if we could figure out that length, then we could get the height of the triangle. Because we know that the slant height here, that thing, is 9. Right? That's the same as this guy right here. I just moved it over to this diagram instead. So what we really need now is this length, y. Okay? Well, notice that cuts that 7 into 3.5 and 3.5. And y goes from the center of the triangle to the center of the 7, which would be this length right here.
It's actually BC, but it works the same way there if we wanted to do it that way. So I'm going to call that equal to y. Right, that's the same thing as this one here. Okay, so let's try doing this. Let's cut this up. If I do that, I just cut that 60 in half. So that's 30, which means this little triangle is also a 30, 60, 90, just oriented differently. So 30 here, 60 here. In the 30, 60, 90 theorem, this would be 1. This would be the root 3, and this would be the 2. So now y goes with 1, the same way that 3.5 goes with root 3. So y equals 3.5 over root 3. So let's just convert that to a decimal, because that's already pretty ugly. So that's about, where is that? About 2.0207. So up here, let's see, I'll use this color. That thing, y is 2.0207. So I can now do Pythag. 2.0207 squared plus the height squared equals 9 squared. If I work that out, I would end up with, let's see, the height equaling 8.77021. So now we can come back down here and say that this is 8.77021. The area of the base is this guy that we solved for earlier. And the height we said was 8.77021. And if you multiply all that out, you end up with 62.028 centimeters cubed. All right, hope that helps a little bit.